Hello everyone. So today we'll be going through step by step how to answer a very common type of redox question. So let's take a look at the question. One of the uses of ammonia is in the manufacture of nitric acid, and this is done by a two-stage process. So stage 1, ammonia is converted into nitrogen 2 oxide, and this is the equation. Okay. Then stage 2, nitrogen 2 oxide is converted to nitric acid, and this is the equation. Okay, so explain in terms of oxidation states why stage 2 is a redox reaction. So for this type of question, the first thing we have to do is to identify the oxidation states of all the elements in the reaction. Okay, specifically with this reaction, because we are talking about stage 2. So first, I will look out for all the hydrogen and oxygen. Okay, because most of the times, if they are in a compound, oxygen will be -2 and hydrogen will be +1. Okay, so I look at NO, oxygen is in a compound, so it's -2. H2O, oxygen is -2. Okay, 3O2, the oxidation state is always 0. Okay, doesn't matter which element. Any element by itself, the oxidation state is 0. And then HNO3, oxidation state will be -2. Okay, then now I look out for hydrogen. Okay, so hydrogen in H2O will be +1, and hydrogen in HNO3 will also be +1. Now let's see what I'm left with. I'm left with nitrogen here and nitrogen here. So how do I find the oxidation state of nitrogen? We'll start with NO. Okay, so since NO is a neutral compound, the total oxidation state of all the elements will be 0. That means oxidation state of N plus oxidation state of oxygen equals to 0. Okay, let me write 0 like that. So we know that oxygen is -2, right? So we just sub in -2. Okay, so N -2 equals to 0. So oxidation state of N is +2. Okay, what about N in HNO3? Same thing. All the elements, oxidation state equals to 0. So H plus N plus 3 oxygen equals to 0. Okay, and there is 3 oxygen because here there's a number 3. So there are 3 atoms of oxygen. And then we just sub in for hydrogen, which is +1. Okay, then N is unknown. And oxygen is -2. So 3 times -2. Okay, so N plus 1 minus 6 equals to 0. N minus 5 equals to 0. And oxidation state of N is +5. Okay, +5. Now, a redox reaction involves both oxidation and reduction. So we have to figure out what substance is being oxidized and what substance is being reduced. If the oxidation state increases, that is oxidation. So let's look at which element did the oxidation state increase. So nitrogen, it went from +2 to +5. Okay, so how do we write this down? How do we explain it? First, you mentioned that the whole compound is oxidized. So NO is oxidized. Okay, that is your statement. Then now you have to explain it in terms of oxidation state. Okay, because the oxidation state of what element are we talking about here? Nitrogen. Okay, and the oxidation state of N increases from +2. Okay, and where is the +2 from? It's from NO. And it increases to +5 in HNO3. Okay, so notice how at first I state the oxidation state, which is +2. Then after that, I mentioned where did the +2 come from. The +2 is from NO, and then the +5 is from HNO3. Okay, and that is a simple explanation that you need. Next, let's find what is being reduced. So the oxidation state of oxygen went from 0 to -2. So that is a decrease. So I can say O2 is reduced. Because the oxidation state of O decreases. Okay, because this is reduction. So it decreases from what? From 0 in O2 all the way to -2 in HNO3. Okay, so I explained it's being reduced because the oxidation state of O decreases from the oxidation state 0 in O2 to the oxidation state -2 in HNO3. Okay, then finally I'll just say, because we want to answer the question, right? Why stage 2 is a redox reaction? Since stage 2 involves both oxidation and reduction, it is a redox reaction. Okay, and that is how you answer redox reactions in terms of oxidation states.